Hello children, today our topic is graphical representation of linear motion. Okay, what does this mean? Whenever I am saying linear motion, it means a body moving in a straight line. Alright, and the graphical representation, that means I will visualize how the motion is and I will draw in the form of a graph. Alright, you know a graph which has an x-axis and a y-axis, and then on that we are going to plot how the movement of a person is. Let us say, for example, you are going to school and you go by bicycle. Alright, so how will you start? You start from rest and then you accelerate, and let us say you develop a speed of 5 meters per second. Alright, you travel on that speed. You travel with that speed for some time, and then you see your friend who is riding ahead. What do? You accelerate and you increase your speed a little until you reach your friend. Okay. After that again you travel together for some time and then you almost reach school. So you slow down and finally at the gate of the school you stop. Okay, now this I am going to draw, or rather I am going to plot it in the graph. I have done a little here, like for example, this x-axis denotes time and the y-axis is my speed or velocity. Okay, now here velocity means speed in a particular direction. Now, we have started from rest, remember, so I start from 0. Then slowly I accelerate at, now my speed is 5 meters per second. Okay, for some time I travel by the same speed, right? So it will remain as a straight line. Okay, then I see my friend and I again accelerate. So it moves upwards. What is my speed now? Now my speed is 10 meters per second. Okay, then again what did I say? Two friends are traveling together at the same speed for some time. Okay, and finally what do? They reach school. So they slow down and then finally again they stop. So what will be the speed now? The speed here is 0. Now let us see how much of time. Let us say for here it was 10, then 20, then 30, then 40, then 50, and this let us say 60. So if this is time in minute, then what do I say? By 55 minutes they both reach school. Okay, so from here I can deduce the time when they reach school, the time when he increased his speed, the time till 20 minutes he was at which speed? 5 meters per second. Then at what time did he meet his friend? At 30 minutes he meet his friend. Okay, so likewise from the graph I can gather a lot of important information. Okay, now let me draw another graph and let's see what we can deduce from that. Alright. Now I will draw a displacement time graph. What do you mean by displacement? Change of distance from one place to another. So this is a displacement time graph. I'll just write it here. Displacement, it should be actually within this displacement time graph. So maybe I'll just rub this out. Okay. Now here again I plot time. So I will write here time. This is my x-axis and this is my y-axis. So y-axis is representing displacement, that is moving from one place to another, and this is showing time. Now I am dividing this into, let us say 5, 10, 15, 20 seconds. Okay, and this also, let us say 5 meter. So I have to write here time in second, and here I will write displacement in meters. So from here I can realize, like what are the units: 5, 10, 15 and so on. Now in this graph, my graph is showing just a straight line like this. What do I infer from this? Let us say at 5 seconds, the person was at 10 meters. Okay. At 10 seconds, the person was still at 10 meters. At 15, again the same position. At 20 seconds, again the same position, 10 meter. So, can you deduce from here? Is the person at rest or in motion? The person has certainly not changed his position. So, I can deduce from here that the person is at rest. Okay. Now we go to the second one. Alright. Now my graph is like this. Now what does this show? This again is my time in second, and this again is my displacement. Okay. So what does it show? At 5 seconds, the person was at 5 meters. Again at 5 seconds, the person is at 10 meters. Sorry. Okay. At 5 seconds again, 15 meters. Now take a pause and think. Is it possible that at the same instant you are changing position? It is not possible, right? Therefore, this is a wrong graph. Okay, or this is an impossible thing to do. So graphs are very interesting, children. You can plot your movements, or the motion of a car in this kind of graph. Now I will draw another graph. This is a line that is going straight like this. Okay. Now let us see what we can infer from here. At 5 seconds, it has travelled 5 meter. Okay, I'll just draw it this way. Okay, then again at 10 seconds, it has travelled 10 meter distance. Okay, at 15, let us keep 15 here. How much distance has it travelled? 15 meter. Alright. Now, can we deduce the speed from this graph? Now, we know speed is equal to distance by time. So, what is the speed here? It is 5 by 5. So, it is 1 meter per second. Okay. Again, what is the speed over here? 10, distance by time. So 10 meter by 10 second. Again 1 meter per second. In the third case also it is 1 meter per second. Though it is very less, but what we can realize from here, that this body is moving. Okay, it is changing its position, but at a uniform speed. Right? So, if the line is moving like this, then what does it denote? That the speed of the body is uniform. Alright. Now suppose you are given a graph like this and you are asked to find out the speed. Okay. Now this is not there and this is also not there. Only this much is given. And you are asked to find the speed. What will you do? No worries. You know this line has a slope. Okay. So I will just draw a perpendicular from here and a perpendicular from here. and I'll name it A, B, C. Okay, now what will be the slope of this line is the speed. So this is, we know the slope of this line is y-axis by x-axis. So it will be 15 minus 10, and this is C minus A. So again 15 minus 10. This is the x-axis. So how much does it come? 555, which is 1 meter per second. Doesn't it tally with the earlier answer? Yes, it does. So if you are asked to find the slope, it is nothing but you will just say it is equal to y-axis by x-axis, and then you put the values, you compute the values over here and you find out the answer. Alright, thank you class.